In this recording, you'll learn how to keep track of uncertainties while adding, subtracting, multiplying, and dividing the quantities with uncertainties. You'll also learn how to properly round the measurements taking clue from significant figures. Let's get started. Before we jump into the propagation, let's take a moment to talk about the relative uncertainty. You need to use relative uncertainty for propagation most of the time. From previous recordings, you are already familiar with the fact that we need to write any measurements in terms of measured value plus minus uncertainty with a proper unit. The relative uncertainty is just fractional uncertainty, often expressed in percentage. So in terms of this symbol here, this is going to be delta L over L. If I plug corresponding numbers and multiply by 100, that becomes percentage. As you know, to go from fraction to percentage, you have to multiply by 100. Now you are ready to talk about propagation. Here I will focus on a method known as quadrature method. Just for record, there are other methods. Quadrature method works like Pythagorean theorem. You make two sides of a right triangle out of known relative uncertainties. The relative uncertainty of the result is the hypotenuse. To find the ratio of resulting uncertainty by adding the squares of each relative uncertainties and taking the square root, just like a Pythagorean theorem. Finally, multiply the fraction by the result of the math operation. We got this fraction and we are multiplying that fraction by the result R, and that gives us the uncertainty on the resulting quantity. For special cases like adding and subtracting two quantities with same units, you can just use quadrature of the uncertainty. You don't need relative uncertainty, which means no fraction necessary. You just square this number and this number and take the square root if they have same units and you are just adding or subtracting. So you can think of this as special case. Let's talk about when we have power. For example, b squared as in here. You multiply the relative uncertainty with a factor before you square it. As you can see, rather than just being the relative uncertainty or this fraction here, there is this factor 2 that came from the power of this b. If we have a square root instead of square, you can think of a square root as power half. This half is going to multiply that factor. The same rule applies whether the power is in numerator or a denominator, just like we saw in this example. If it was a cubed, then the 3 would be multiplying the relative uncertainty of a. Now let's spend some time learning about how in some cases we may have to reduce the significant figures of measured quantities based on the decimal place of the uncertainty while rounding. Suppose a group of 5 students measured the height of a person and they found these numbers. And then they found the average and uncertainty of those 5 numbers and they wrote their result. The uncertainty in this measurement starts at second decimal place, not on third, as one might assume based on the list of measurements. In this case, you round the average to second decimal place to match with the decimal place of uncertainty. And by the way, we round the uncertainty to one significant figure most of the time unless the number here begins with 1. When that is the case, we may keep 2 sig fig. For example, if this uncertainty was 1, 4 instead of 2, 4, we may have kept 1, 4 rather than just rounding to 1. Thank you for your curiosity and time.